This is Amanda Martinez, and this is my reassessment on circular motion. So the question I did ask for you to find the max speed of the car if no friction is needed to find the centripetal force. So I drew my free body diagram to label, so I could show and label all my forces acting on the car. And you have mg going down and Fn going this way. And then I knew that to find the max speed, you have to use Fnet, Newton's second law, Fnet equals ma. And then to use Fnet equals ma, you have to resolve all your forces, and mg is already resolved, so you have to resolve the normal force, Fn. So once I redefined my x and y axes, I resolved Fn, the x component of Fn, into Fn sine 31, and the y component of Fn into Fn cosine 31. Then I use my components to make my equations for the x direction and the y direction. And for the x direction, I got Fn sine 31 equals ma, or equals mv squared over r. And for the y component, I got Fn cosine 31 minus mg equals 0, and Fn minus mg because Fn is in the positive y direction and mg is in the negative, so mg should be negative. And the reason it's 0 is because the acceleration in the y direction is 0, so which makes that 0. So then, in order to find the max speed, you have to use the x, because you're only going in the x direction, so you have to use the x formula, the one for the x. And in order to find velocity, you have to know everything else, but we don't know what the normal force is. So in order to find the normal force, you have to use the y equation of Newton's second law to solve for Fn. And once I do that, you get Fn equals mg over cosine 31. And then after you get what the normal force is, you can find out what v is by solving for v. So first you just cancel out your m's, and then you multiply by r on both sides, and then you get v equals the square root of gr sine 31 over cosine 31. And once you plug in all your values, you get that the max speed of the car, it needs to be 40.26 meters per second.